let's go to the state transition table of JK and SR flip-flop. This is your last class. Today, state transition table we have to develop, for which we need the first the truth table of JK flip-flop. It's 0 0 means QN, 0 1 means 0, 1 0 means 1, 1 1 means QN bar. SR is 0 0 means QN, 0 1 means 0, 1 0 of 1, 1 0 means 1, 1 1 means toggle. Now, state transition table. Listen to me very carefully how to develop the state transition table. We have one set for JK flip-flop, one set for SR flip-flop. JK, there is no case of toggle. In case of SR, there is a case of toggle. So 1 1 is excluded from the truth. 1 1 input is excluded from the truth table. So 0 0 QN to QN plus 1 changing. QN is like that 0 1 0 1 0 1 0 1. Okay, we'll get 8 combinations for 3 inputs, 8 combinations. In case of SR 1 1 0 SR QN 1 1 0 1 1 1 excluded because 1 1 we have toggle, we have output is toggle, so no 1 1. Now understand it very carefully. 0 0 input is 0 0, QN plus 1 is 0 because 0 0 means QN. If QN is 0, QN plus 1 0. If the input is 0 0, QN is 1. So QN plus 1 will be 1 because 0 0 means QN plus 1 will follow QN. 0 1 irrespective of 0, input is 0 1, input set is 0 1. We have 4 sets. We have 4 sets. 2 sets. We have 4 sets. Each set contains 2 input. 0 0. This is 1 set. This is 2 set. This is 3 set. This is set number 4. So each set contains 2 inputs. 2 input set. This is a 2 input set. First input 0 0. We know that 0 0. If QN is 0, QN plus 1 is 0. Second input 0 0. If QN is 1, QN plus 1 will be 1. Now if the input set is 0 1, 0 1 and 0 1, irrespective of 0 or 1 in QN, output will be 0, QN plus 1 will be 0. Now input set is 1 0. 1 0 means in JK it's 1, QN plus 1 is 1. So irrespective of input 0 or 1, input may be 0, input may be 1, QN plus 1 will be 1. Both cases QN plus 1 will be 1. So and if input set is 1 1, if so QN is 0, 1 1 means QN plus 1 becomes QN bar. 1 1 input is QN is 0, output is 1, QN plus 1 will be 1. Input QN is 1, output QN plus 1 will be 0. It is opposite to the reverse or complement of 0 or 1. So if your input set is 1 1 in both the cases, if QN is 0, QN plus 1 is 1. If QN is 1, QN plus 1 will be 0. So let's make the state transition table. Listen, very carefully observe it. In which of the cases we are finding the 0 to 0 transition? Here 1. 1 in here, 1 in here. So let's see the output 0 0 0 1. The state transition table is 0 to 0, 0 to 0. Transition is 0 to 0, 0 to 0 to 0 in 0 0, 0 to 0 means in 0 1. So 0 to 0 means 0 don't care. K may be either 0 or 1. So input is change is 0 to 0 means 0 don't care. In which of the cases we have 0 to 1 now state transition table has 0 to 1. State transition table change is 0 to 1. In which of the cases we find 0 to 1 change? Here. 1 is here, 1 in here, 1 in here. So 1 0 1 1. 1 0 0 to 1 state change. 1 1 0 to 1 state change. So 1 0 and 1 1. 0 to 1 means 1 don't care. Now 1 to 0 state change. 1 to 0, 1 in here, 1 in here. So 0 1 1 1. So here change is happening 0 and 1. 1 remains constant, both the cases. So 1 to 0 means don't care, 1. Here the change is happening 0 or 1. 1 remains constant in both the cases. State change is 1 to 0. In 0 1, in 0 1 and in 1 1. So 1 remains constant, 0 and 1 both are changing. So 1 to 0. 1 to 0 means don't care, 1. Don't care, 1. And now it's 1 1. 1 to 1. 1 to 1. 1 to 1 means 0 to 0, 1 to 0. 0 to 0, 1, 1 to 1 cases. 1 to 1 state change. One last state change is 1 to 1. 0 to 1. 0 to 0 and 1 to 1. 0 to 0 and 1 to 1. So where? So 0 to 1 to 1. 0 to, sorry, 0 0 and 1 0. 0 0 and 1 0. 1 to 1 state change. 1 to 1 here, 1 to 1 here. So 0 0 and 1 0. So which is constant? 0 is constant in both the cases. Changing, we are changing here 0 and 1 in J. So 1 to 1 means don't care, 0. So remember this truth table. 0 to 0, 0 don't care, 0 to 1, 1 don't care, 1 to 0 don't care, 1 to 1 don't care, 0. This is useful for your counter design. You don't have counter design in your syllabus, but you have basic knowledge. You need to have basic knowledge about counters, so and different types of counters and registers. But this design is important, this state transition table is important in the design methodology to know and to design every type of counters sequence. Now let's go to the SR flip-flop. 0 0 means if Qn is 0, here also 2 set number 1, 2, 3. Each contains two set of inputs. Set 1, 2, 3. So if SR is 0 0, Qn to Qn plus 1. SR 0 0 means Qn plus 1 will follow Qn. So it is 0. SR is 0 0. Qn is 1, Qn plus 1 is 1. 0 1, Qn is 0. So output Qn plus 1 will be 0. 0 1, Qn is 1. 0 1 means 0. In both the cases, irrespective of 0 and 1, Qn plus 1 will be 0. In both the cases. Now 1 0. 1 0 means SR truth table, it is 1. Irrespective of 0 and 1, in the Qn plus 1 will be 1 in both the cases. Set number 3. Now set number 1, 2, 3 we have completed both the we have completed the entire state transition table. Now see the state changes. 0 to 0. 0 to 0 means where are we finding 0 to 0 change? Where we are finding 0 to 0 change? Here and here. So 0 0 0 0 and 0 1. 0 remains constant, both the cases. Only R, the 0 and 1 is changing. So 0 to 0 means 0 don't care. Then 0 to 1. 0 to 1. 0 to 1 we are finding only here. 1 0. So 0 to 1 means 1 0. 1 to 0. 1 to 0. 1 to 0 means here. Here only 1. 1 to 0. Here only the 1 to 0. That means 0 1. 1 to 0 means 0 1. And last change is 1 to 1. Here 1 0. Here 0 0. So which one? 1 0 and 0 0. Which is common? R is common. 0 is common. So change is here 0 and 1. So 1 to 1 means don't care, 0. So remember this truth table also. 0 to 0 means 0 don't care. 0 to 1 means 1 0. 1 0 means 0 1 and 1 to 1 means don't care, 0. Only the difference between JK and SR is in case of JK we write 1. 0 to 1 means 1. 0 to 1 state change means 1 don't care. 1 to 0 state change means don't care, 1. In case of SR, instead of writing don't care, we write 0 to 1 means 1 0. 1 to 0 means 0 1. 0 to 1 means 1 0. 1 to 0 means 0 1 and 1 to 1 means don't care, 0. 1 to 1 means don't care, 0. Why don't care, 0? 1 to 1 you see 1 0 0 0. The state changes because 0 0 q irrespective 1 to 0. In case of 1 0, irrespective of 0 and 1, output is 1. Qn plus 1 is 1. In case of 0 0, if Qn is 1, Qn plus 1 will follow Qn. It is 1. So 0 0 and 1 0. 0 is common, R is common. Only we are finding the change in S. Only we are finding the change in S. 0 and 1. We are finding the change in S. 0 and 1. So 1 to 1 means don't care 0. Don't care 0. So it's in case of D. In case of D is a simple latch. D is a simple latch type flip flop. Output follows the input. So 0 to 0, 0 to 1, 1 to 0, 0, 1 to 1. Qn plus 1 is 0 1 0 1. D is 0 1 0 1. So we have completed the entire state transition table. Remember, this state transition table is very important for your design in counters. If you are designing counters like this, presence 0 0 0, Qn, Qb, Qc, 2. QA, QB, QC. This is QA, QB, QC. This is present. This is next state. Like 0, 1, 0. So 0 to 0 means in JK, J1, K1, 0 don't care. 0 to 1, J2, K2. Flip flop number J2, K2. 3 bit means 3 flip flops. 3 bits means 3 flip flop for each bit. 1 bit flip flop is assigned for 1 bit particularly. So 0 to 1 means 1 don't care. From here, 0 to 0 means here, 0 don't care. J3, K3 is 0 don't care. This state transition table is very important to design the counter sequence in any type of counters, like binary to gray code counters, like any type of, we are assigning you this way, 0 0 1 to 0 1 0 to 1 0 1 to 0 0 0 0 0 0 to 1 1 1 to, this is called a counter design. This is called the sequence table or sequence cycle of a counter. So 0 0 1 to 0 1 0, 0 0 1, 0 0 1 to 0 1 0. How can we find that changes? 0 0 means in JK flip flop, if we in the counter we use mainly JK flip flop to design. So 0 0 0 0 0 1 to 0 1 0, 0 to 0 means 0 don't care, 0 to 1 means 1 don't care, 1 to 0 means don't care 1. Right, in like this way, 0 1 0, from 0 1 0 we are going to 1 0 1, 0 1 0 we are going to 1 0 1. So 0 to 1 again, 0 to 1, 0 to 1 means 1 don't care, 1 to 0 means don't care 1, 0 to 1 means 1 don't care. In this way, we design the counter sequence table. One sequence table is given to you. You will have to use this flip-flop state transition table to design the counters. So, this state transition table is very important to in order to design any type of counters or any type of binary sequence table design. This is a binary sequence table or sequence cycle. With the help of this sequence cycle, you design counters, and this state transition table is highly required. You need to know this state transition table: 0 to 0, 0 don't care, 0 to 1, 1 don't care, 1 to 0, don't care 1, 1 to 1, don't care 0. At least for JK and for SR also, 0 to 0, 0 don't care, 0 to 1, 1 0, 1 to 0, don't 0 1, 1 to 1, don't care 0. So at least JK and SR, you need to know the state transition table to design a counter or to develop a counting binary sequence. So we have completed the entire flip-flop. Now in the next class we will go to counter. You have in the counter first we know what is counter and how the counter is designed based on the clock pulse triggering. How the counter is designed based on clock pulse triggering, and that means positive edge triggering, negative edge triggering. How we are designing up and down counter, and then we will go to straight away we will go to some go to the design of some counters in your syllabus. You don't have counter design from this binary sequence like this. You don't need to learn the counters design by using binary sequence. These are tough, but you need to design. You need to know what is the basic principle of the counter or basic physics behind the counter design, and how we are designing the counter, up and down counter by using clock pulse triggering, and then you need to learn some of the some different types of counters diagram with the diagram table, with the state design table, and then we will go to register also.